Of upsets. I lost my partner, I lost my parents, and my partner left with our two children in the middle of the lockdown. So I guess I was getting pretty lonely.
So, who we are and why we participated in the hackathon. I'm Magdalene Harmina, a founder of an AI powered platform for sales automation and intelligence. Like many of us, I have elderly family members who struggle with technology, still forwarding each suspicious link they receive to everyone around. And they are completely unaware of the fraud networks behind these links. Working also extensively on AI agents made me aware of how powerful these tools are. However, I'm also aware how they can be weaponized against our most vulnerable. The statistics I discovered in the past few weeks were even more shocking than I ever anticipated. And working alongside Devish was an immense learning experience. And we are excited today to show you the results of our work on ShiElder AI.
Hi, I'm Devesh. I work in GenAI, primarily working with LLM-based application and RAG systems. I participated in this hackathon because I wanted to learn about how knowledge graph can be leveraged to enhance our traditional RAG systems. That's why we built this project. So this is our hackathon notebook. For the data set, we took inspiration from a couple of real world fraud detection data set, and then we built our own synthetic data set for our use case. As you can see here, we have in this data set, we have a couple of fields like transaction ID, sender account, sender age. All these fields we have used to enhance the capability of our graph so that it can produce better results for the agent. and this is how and this is how we have converted the data set into a network graph. So first we took the data and we built a multi-directional graph using network X to represent financial transaction. Since fraud rings often involves multiple transactions between the same accounts, we used a multi-die graph which lets us track edges between two nodes. First, we create the graph from our data set where sender account and receiver account are the nodes, and things like transaction ID, amount, date, and font type become edge attributes. Then we add more detail to the each account like age, gender, and whether the person is elderly, because detecting fraud patterns targeting senior is a key focus of our project. Finally, we assign all these attributes to our graph and print out a sample node to check that everything looks good. This structured graph is the foundation of our AI driven fraud detection system. After building the graph, we stored our graph into Arango Graph cloud database, and this is how we connected to our cloud database. As you can see here, this is how we connected to our database. So this is the sample of our bigger graph. This is how it looks like. All these nodes that you see in the middle are the fraud accounts, which are connected to multiple elderly accounts. Let's zoom into this graph, and here you can see multiple edges are directed towards these centered accounts, which are fraud accounts. So here you can see the information is elderly is zero here, so which probably means that this is a fraud account. So there are total of 1,000 nodes and 10,000 edges in this whole graph. So this is just a sample of this graph. All right, so now let's take a look at how we build the agent, which is the main thing of our project. So I've used Grok API to for our base LLM, and these are the tools that we have used: test to AQL to test, and text to NX algorithm to text. So I have done some prompt engineering to enhance this tool. Now let's try to run some queries. So this is the we have built a classifier agent which classify the query based on the user query. So here we are running the classifier query agent, and this is a function that we have built to which directs the selected tool to execute the tool. So here is our main. So now let's run a simple AQL query that we have: show transaction flagged as fraudulent. So we'll run this query, and here is you can see that we have the decision text to equal to text. This is our classifier agent that is running, and here is so we have got the result from the equal query. Now the agent is processing this into a natural text. So we have got our result. So there are a total of 20 transactions so that have been flagged as fraudulent. So which this is the limitation of Arango graph, because it just take into account top k samples from the whole list of entries that it returns. Okay, so now we'll run a complex query on our graph. So here is this query: find the top accounts that have the most influence in fraudulent transaction, considering both direct and indirect connection. So we'll run this. So here our agent has detected that as it needs algorithm tool, and here is the code that it has generated. We can see that it shows the algorithm page rank to find the most influential fraudsters in our graph, and here is the result that it has returned. So there are a total of 5 accounts with this between centrality, and this is some insight that the LLM has generated based on the result. So this is all about our agent, and this is how it works. We have mainly spent more time on prompt engineering, defining how the agent will execute queries. Like on this algorithm tool, we have tweaked with multiple prompts to get the best prompt which gives the best results.
Okay, so this is our solution, ShiElder AI, for a real world problem which we identified. This may not be the best solution in terms of technicality, but we aim to integrate a whole system so that it becomes reliable and can be integrated with financial institution. That's all. I hope you liked our project. Thank you.